Hey folks, my name is Noah. This is Ryan, Daniel, and Spencer, and we are Team 11 Turtle, tracking and uploading relative turtle locations in the environment. And we're working with the College of Natural Resources with Dr. Molly. The purpose of our project is to develop a turtle tracking system, one that allows for a much more frequent data and for autonomous data collection. The College of Natural Resources does have a system for collecting data on these turtles, but their system is very labor intensive. And so we're looking to develop something that does not require so much effort. Understanding where these turtles, what their behavior is really important for forest management, making sure we're not interfering with the turtles, and also for understanding changing environmental conditions. In terms of what this system needs to do, we want to get autonomous, daily, and accurate position data. Accurate to within 5 meters for each fix that we get. Autonomous, so researchers don't have to go out into the forest, and daily position data. And we also need to make sure that we're not harming the turtles in any way. So that means that we're not mounting too much stuff to the turtles, no more than 12 grams of components, and again, that we don't have to go out to the forest too often. Maintenance no more than once per month. So we investigated various technologies. This was an exploration-based project. We decided to pursue a GNSS, or Global Navigation Satellite System-based approach, where we determine the turtle position by getting a fix from satellites and sending that information off to a base station where the fix is processed and then uploaded to Google Drive in an easy to parse, easy to use for researchers CSV format.
So one of the biggest challenges here, of course, is the weight, being under that 12-gram limit. So to accomplish that, we worked on designed a custom PCB that was able to meet the weight requirement. However, there's more work to be done on manufacturing that because the components are tiny. They're not meant to be hand soldered. So future work will need to include the PCB. However, the PCB does not have any changes needed that will affect this weight. So the weight is an accurate representation of the final system, and it meets our 12-gram weight requirements.
So we were able to actually demonstrate kind of end-to-end functionality, going from establishing a connection with the tag attached to the turtle in the base station, getting a satellite fix to get the position, and transmitting that back to the base station, uploading it in the user-friendly format up to Google Drive.
Going forward with this project, the next steps that we need to take are really to improve the PCB to make sure that everything is functional, and continue to design a weatherproof enclosure for our turtle-mounted device. Turtles, sometimes they like to go under the water, and we need to make sure we can account for that. Additionally, something we could do to help the researchers in the overall maintenance and operation of our system is to broadcast the battery health along with the position so they could see, the tag is getting low, let's go replace the battery.
Go Pack!